Hello, everybody. Thank you. As was mentioned, this talk is going to be the state of Delve, kind of piggybacking on state of Go. I thought it would be an interesting concept since I've spoken about Delve the past few years at FOSDEM, so it's always nice to come and kind of give an update on what's going on with the project, what's changed. One thing that I feel the need to address right off the bat is if you look at the schedule, you might read some nonsense about hands-on debugging session and this and that. So that was the original plan for this talk, but trying to get basically a workshop into a micro workshop format was kind of difficult, and so I decided to go with a more traditional talk instead. And after watching some of the talks this morning, it actually works out quite nicely because making Francesc act as a microphone stand for 25 minutes, I couldn't do it to him. So I'll save him some of the trouble. Regardless, we'll have a good talk, and I'd like to go over some of the things that have changed since in the last year, some of the things that we'll be looking forward to in the next year as far as new features and developments, and I also would like to take a deep dive into a feature that was implemented within the last year that I think is really interesting. And so we'll get into some more technical things there, which is nice because I kind of like to use this as an opportunity as well to encourage contribution. You know, this is a very open source conference, and a lot of really good smart people here. So always looking for new contributors, and deep dives into this kind of stuff I feel like encourages it. So just to introduce myself after that long-winded introduction, my name is Derek Parker. I'm a senior software engineer at Red Hat. I maintain the Go package for RHEL internally at Red Hat, support all of our internal customers and external customers, and also do some upstream contributions and contributions to the runtime and some other things. Aside from that, I'm also the author, original creator of Delve, and maintainer. I also have another co-maintainer, Alessandro, who I'd just like to give a shout out to because he's been a huge help with the project, especially over the last couple of years. So, state of Delve. Like I said, I'd like to go over what's changed in the last year, what new features have we added, what have we done to keep up with changes in Go and the Go runtime, and additionally after that, what can you expect? What new features are on the roadmap, and what would be, if you would like to contribute, some of the highest impact areas where you might be able to contribute in the future. So just to do kind of like a little recap and give a little bit more backstory to the project. The project is actually about 4.5 years old now, which for me is kind of surprising looking back on it. But it's grown a lot, and tons of people are using it now, which is great. We've gotten a lot of support from the community and a lot of support from a lot of the core team members and things like that, which has been great. And building these relationships with the community and especially the core team is very beneficial and also necessary for implementing some of the features that we need to implement in Delve that might involve coordination with the runtime and things like that. And I'll explain that a little bit more later. The first commit of this project was actually in May 3rd of 2014, which was a little bit after the first GopherCon, which was there was a panel there that was actually the inspiration for the project as a whole. Total, we've had 88 contributors, which is pretty good for kind of a weird esoteric project. Not a lot of people hack on debuggers, so having this many contributors has been great. Again, always looking for more people to come and help hack on the project. So without further ado, I'd like to dive into some of the interesting changes that we've had since last year and some of the give a shout out to some of the bigger features that we've implemented recently. So one of the biggest and most exciting things for us, just as maintainers, was the release of v1.0. So that happened actually, I believe, pretty shortly after FOSDEM last year. So before that, we were considering the project pre-1.0. A lot of folks were still using it, still using the project, still using it very successfully. We actually considered it pretty stable and ready for use, even though for a while we had like a scary message on the repo, saying it was pre-1.0 and all that stuff. But earlier this year, or last year, I guess, we finally released the 1.0 version, and subsequently we've released 1.1. So the version scheming kind of follows the upstream versions. So 1.0 was around the time of Go 110. 1.1 is around the time of Go 111. So subsequently, as we're gearing up for 112, 113, so on and so forth, our versions, our release cadence will, for the minor versions, will map to Go versions. So 1.2 for 112 and so on and so forth. This release marked a bunch of new features and, more importantly, just kind of a feeling of stability, API stability, compatibility for anybody who does IDE integration or uses the API to interact with the debugger. So over that time period, we ended up adding a bunch of new features. So I'd like to kind of take some time and go through, shout out some of the bigger features that we've added. Certainly, there's been tons of new other features, improvements, performance improvements, fixes, things like that have gone in. And this doesn't also cover a lot of the work that we do upstream with helping improve debug information that's generated in Go binaries and things like that. But just as far as the Delve side, over the last year, we've added support for 110, 111, and also 112. So with that, with every new Go release, what we try to do is improve the quality of debug information that's found in the Go binaries. So myself, Alessandro, other folks who do IDE integrations, we try to communicate with the runtime team, the compiler team, and suggest fixes and contribute code where necessary to ensure that when you type Go build, it produces a binary that has as much information as we can possibly get to create the best debugging experience for you. And when Delve builds the binaries, it builds them without optimizations and things like that. We also want to make sure that you have the best chance to debug your binaries and have all of the information that you need. So as new versions come out, we support new missing features that are in, like the dwarf information and things like that are present in the binary. So with that, one of the improvements that we've been able to make is when you're debugging optimized binaries. So when Delve builds a binary for you, if you just type DLV debug, it builds the binary in such a way that it disables all of the optimizations that are enabled by default. So function inlining, variable registration, things like that. And this just makes it a lot easier to be able to debug your binary. But what we also ultimately want to do is let it ensure that you can debug any kind of Go binary and you'll have success. So even production ready, more optimized binaries. Part of what we've done is added more support for debugging inline functions so that you can debug optimized binaries a lot better. Another feature that we've added is support for DWZ compressed dwarf info. This is useful for, so dwarf information, for those who are unaware, this is the information that's stored in the binary that kind of has a bunch of information about the process and the program that you're debugging, which kind of tells you information about what the stack looks like, where variables are in memory, and things like that. How to access all of the things and get all of the information that the debugger is able to then ultimately present to you. Allowing for supporting compressed DORF info is kind of allows for folks to still build binaries with the DORF information enabled, but also get smaller binary sizes because DORF information can take up a lot of space. So as we improve debugging production optimized binaries, adding support for compressed debug information is important as well. Additionally, we've added support for being able to specify separate debug information. So with a lot of binaries that are distributed by package managers, a lot of times there's a separate package for the debug information from the binary package. And so if you install something like this, you can use Delve to specify an alternate debug information file so that you can still debug these programs that have the debug information stripped out of it but still available elsewhere on the system. We've also made improvements to the debug server, being able to run headless without a connection. This is more of an implementation detail, but it's nice to have maybe like a headless server running that you can connect to and disconnect to. Say if you want to run Delve within a container or something like that and run the client outside of it, it makes it a lot easier to do kind of ad hoc debugging if you want to connect and disconnect and not have a session running constantly. Another big improvement is the ability to call functions in the target program. Now this is something that I was very excited about, and this is something that I'd like to take a deep dive into in a little bit. But this was a long time coming. It was a very complicated feature to implement, and as you'll see later, it involves a lot of coordination with the Go runtime just because of Go's memory model, garbage collector. There's a lot of really complicated things when it comes to calling a function in a target Go program that we had to overcome. So this was a big collaboration between us on the Delve team and a couple folks from the Go runtime team. So I'm really excited about it, and it's something that we've been looking to add for a really long time. Some other niceties. We have added just an edit command. So similar to if you're used to any other debugger, wherever you're stopped in your program, you can type edit. It'll open it up in Buck editor, and you can start editing your program or viewing your program that way from wherever you're stopped at in the debugger. We've added support for position-independent executables. This is just another nicety. If you're building Pi binaries through your build system or for production reasons, security reasons, anything like that, you can now debug those binaries with Delve. Another feature is we finally got the information that we needed from the debug information in the binary to be able to show return values when you're doing CLI tracing. So similar to doing like strace or something like that, you can trace your Go program from Delve without having to start up like a full debug session. And with this feature, you don't need to do print line debugging. So you can just trace your program from the outside, print out any information that you need about variables, or you can even generate a stack trace and do all kinds of interesting stuff without having to do a full debug session and litter your code with a bunch of print lines and all kinds of other stuff. Additionally, there's been just performance improvements. This is mostly for like IDE integration and stuff like that, but we've done a lot of memory caching, so we're not reading from the process memory so much, and some improvements regarding being able to list like Go routines and stuff like that. Another small thing is the repo has been moved from my personal GitHub account to the Go Delve organization. Nothing's really changed, just the location of the repo, but something worth mentioning, I suppose. So another thing that I want to talk about is upcoming features. So things that we'd like to do within the next year that hopefully maybe I can tell you all of these things have been done next year at FOSDEM. So some of the big things, support for 113, of course, which should be coming out next year. Like just improving the debug information upstream, improving how we parse that and use that information, and so on and so forth. So if you're ever interested in some of the upstream debugging changes that are happening or are currently in flight, if you go to GitHub and look at the Go issue tracker, there's a debugging label. So you can always take a look at that if you're ever interested in the state of upstream debug support. We want to continue adding support for debugging optimized binaries. A big one is adding support for more architectures. Right now, our support matrix is x86-64. And so we want to add ARM, 32-bit architectures, things like that. And this is a place where community contributions can really shine. Another huge feature that we're looking to add is supporting a scripting language. So instead of just interacting with Delve through the API, we're looking at adding a integration with a scripting language. Right now we're looking at Starlark, which is the programming language used for, I forget the name of the build system. Yeah, Bazel. It's it's used for that. So we've been talking with Alan Donovan and trying to see what we can do to integrate that. But you'll be able to define your own functions, and it'll really make the experience seem a lot more interactive. We want to improve Go routine inspection, so just show you more information about Go routine, more information about like the Go routine stack, where it's located, the size of the Go routine stack, things like that. Improve process inspection, so just making like /proc information available, showing page mappings and things like that. Improve stack frame inspection, improve function calling. So there's some limitations to function calling, which I'll get into, but I'm getting short on time, so let me just jump into that so we can get the deep dive into the function calling. So as I said, this was a really interesting feature, and it took a lot of coordination. So I kind of wanted to just dig into it and show everybody how it works, and just share something that I thought was pretty exciting and a really cool implementation. So the syntax for calling a function is just this. So you call whatever your function is. You can pass it arguments. There's some limitations on which arguments you can pass, but I'll get into that a little bit later. You can also call methods. There's limitations there, just because in reality what's happening is the method receiver is being passed as an argument. So same argument limitations apply. But again, I'll get into that later. So in order for Delve to make a function call in the target program, there's a procedure that must be followed. So I want to talk through that right now. So when you type call myfunc, what actually happens underneath the hood is Delve does a bunch of stuff. So it checks Go routine state and makes sure that the Go routine is actually running. So that's a limitation that we have right now. The Go routine has to be running. It pushes the current PC on the stack. It writes the argument frame size, and it writes this on the stack as well. And this is to communicate with the Go runtime. So the Go runtime needs to know how much space we need for a stack to call whatever function that we're trying to call. We save machine registers. This is just because if you call a function, it's going to do a bunch of stuff. It could clobber registers, things like that. So once the function call is over and we return back to wherever we were, we want to make sure that we haven't permanently changed the state of the program. We set the PC to runtime debug call. So when I say PC, that's the program counter register. So we tell the CPU, when we tell you to continue again, start executing the code at this address. And the runtime debug call v1, that's the integration with the Go runtime that we use to make this happen. And then following that, we just continue execution. Then what happens is we switch back to the runtime. So since we told the processor to execute this to execute this runtime function, it starts doing all of its things. So it copies register contents to stack. This is for the GC to be able to, if there's any pointers in the registers, it allows the garbage collector to still have to still see those. It performs some safety checking, and it allocates a stack frame for the function call, setting the stack pointer register appropriately. And then it communicates to Delve through the AX register. So it sets the AX register to 0, and then what it does is it calls int3, which is a like breakpoint interrupt that that debuggers listen to, and it will essentially transfer control from the target process executing runtime code to the debugger to do what it needs to do next. So state of execution transfers back to Delve. Delve will, on the new stack frame that was allocated, it will write the argument frame. So when arguments are passed to Go functions, they're passed on the stack. So it writes all the arguments on the stack. It sets the trapped PC as return. So the trapped PC in this case is where the runtime code left off. So what this does is when the function that we're calling is done executing, it's actually going to return back into the Go runtime instead of returning wherever else it might have returned. And then it sets the program counter to the called function, and it resumes execution. Basically doing like a jump and allowing the function that you wanted to call to execute. Once that happens, the function executes. And once it's done executing, since we set the return value, it returns into the runtime, and the runtime sets the AX register appropriately to communicate what happened back to Delve. So it sets the register to 1 if the function call was successful. If the function panics for any reason, the runtime actually wraps that and will set the register to 2 and allow Delve to read the panic reason and report that back to the user. And then it does the same breakpoint instruction to switch execution context back to Delve. And then Delve reads the return values on success from the stack, and then or reads the panic message on failure. That's pretty much the whole procedure. I thought that was really interesting, so I want to take a deep dive into it. So there's some limitations, and I'll go through those pretty quickly. So only pointers to stack allocated objects can be passed as an argument. This is because we don't have like escape information present in debug info right now. So if you pass a stack argument and the function that you pass it to makes that escape to the heap for whatever reason, we're not able to really track that and warn you of that. So that could cause weird memory corruption issues. We do some automatic type conversion for you when you supply arguments, but only some are supported. They can only be called, or functions can only be called on running Go routines, and the current Go routine that you're calling from needs to have at least 256 bytes of free space on the stack. Functions can only be called when Go routine is stopped at a safe point, and calling a function will resume execution on all Go routines. A feature that we want to do is being able to just continue one Go routine while this function is being executed to minimize side effects, but that'll require more cooperation with the runtime team, and so hopefully we'll get that done in the next year. And it's only supported on Linux and OS X right now. So we're going to continue adding support for that as well. And that's everything. So thank you so much.